So the first antiderivative or whatever just integration formula, indefinite integral formula, is the antiderivative of any constant. You just tack on an x, right? Because if you take the derivative of this, you just get regular k. Because if you take the derivative of a constant, it goes away. So that's the first formula. Just note that if you have the integral of just dx, that's the same thing as the integral of 1 dx. Just people get confused with that. Sometimes you write it like that because there's just a 1 there. So just be aware of that, and then I'll write down more formulas. We have our power antiderivative, the normal power rule for the antiderivative. We had that on the last video. If we take the antiderivative of x to the negative 1, which is the same thing as 1 over x. Remember, you take the derivative of something and you get 1 over x. What was that, the antiderivative for that? Well, if you think about it, you'll remember that it was the natural log of x, ln of x. However, we have to do something special for this. This is plus c. So it's not really the natural log of x, but it's something a tiny bit different. Here, we're allowed to plug in negative x's. But as soon as we go back to the natural log can't accept negative numbers. So what you have to do to remedy this is to make it the absolute value. And why is that? Because we are allowed to plug in negatives here. The absolute values now allow us to plug in negatives here. So now it's valid for both. You can't plug in 0 for this. You also can't plug in 0 for the natural log. So that's why we have to have the absolute values, because we're allowed to plug in negatives here, so we should be allowed to plug in negatives to the antiderivative. So we're allowed to plug in negatives here, so we add the absolute values so that we're allowed to plug in negatives there. So that's that formula. Moving right along. Remember, the derivative of e to the x just stayed e to the x. So on this one, I mean, it's very, very simple. The antiderivative is just the same. This is actually, the next one is a chain rule, like the inverse of a chain rule, but we're just going to write it down as a formula. If we have k to the x there, dx, that's going to be just 1 over k e to the kx, if k is a constant, plus c, right? Because if you take the derivative of this, you have to use the chain rule. That would be the derivative of the outside with the inside the same, so you just copy that down, and then you would multiply it by the derivative of the inside. Well, the derivative of kx would just be k, for k being a constant, and then you would multiply it, and then it would get rid, like it would be k, and that would cancel out. So there's the formula there. K is a constant. And moving on. Actually, that's it. I mean, we do have, like if you have k times f of x, we already know that the property of integral says that you can take this out, right? F of x dx. So, I mean, that we already knew. And you can also split it up along the addition or subtraction. But there we have it. Hopefully it's pretty straightforward. Let's do another example. Actually, let me zoom out. There's all the formulas that we're going to have. Basic integration or antiderivative formulas. There we go. They got bigger as we went along. Whatever. All right, example, what is this? It's 3. So here, find the indefinite integral of 6 times the square root of x minus 5 times the cube root of x plus 2 times the cube root of x squared minus 3. First thing I'm going to do is, kick the thing that I have under my desk. First thing I'm going to do is write down this integral, but using exponents, rational exponents. So I have this now, it's the same thing, and then I'm just going to use the power rule. I mean, it looks kind of weird, but it still should be the same thing. What do? Well, I take my, leave the coefficient there. I take my exponent and I add 1. In this case, it'll be plus 2 over 2, right? Because it's the same thing as 1. So I get 3 over 2, 3 over 2, and then I put on the bottom 3 over 2. This is what I do, and it's a shorter way to do it. So this is, instead of, when I have a fraction, instead of putting that on the bottom like I normally do, I just take the fraction and flip it and multiply, right? Because if you're dividing by a fraction, you can flip and multiply. So notice that I flipped this over, like 3 over 2, 2 over 3. I flipped it over. It's a shortcut. And then I can just reduce right away. So this would be, what, 2 times, that would be 2 times 2 is 4, x to the 3 over 2. And then minus 5, I'll keep that. Here, when I add 1, it'll be a 3 over 3, right? So then I get x to the 4/3. Instead of dividing by 4/3, I flip and I multiply all in one step. So that's actually 3/4. Nothing simplifies there, so it's just minus, what, 15 over 4 x to the 4/3. And then plus, leave the 2 there, add 3 over 3, so I get x to the 5/3. And then instead of doing the 5/3 on the bottom, I flip and multiply. Whoops. So this will be 3/5. Nothing simplifies there, so I get 6 over 5 x to the 5/3. And then the last one is just a constant, so I tack on an x. And then remember, also tack on a plus c value. So there we have it. If I took the derivative here, I would get, what, 6 to the 1/2? Yep. Or 6x to the 1/2. I mean, you could check that, but hopefully it's right. And I just checked it. Remember, check it in your head every time. That way you can be sure you're doing it right. We'll move on to the next video. I'll show you a couple more examples, and then that's it. We're done.